Thank you, Amy. And a big thank you to everyone who are taking their time out of their schedule to be with us today. We always hope that you find our webinars beneficial, and we hope that today's will be as well, as we talk about HSM for Inventor. In today's introduction to HSM, and that's exactly what it's going to be an introduction. So this introduction to HSM for Inventor will start by learning what the initials HSM mean. If you guessed High School Musical, then I know you've got kids and their world has bled into yours, and I'm sorry, that's not correct. HSM actually stands for high-speed machining. So we're looking today at Autodesk's offering for the programming of toolpaths for CNC machining. We'll be looking at the Inventor HSM Ultimate 2019, which comes as a subscription benefit to the Product Design and Manufacturing Collection. So before we get into some of the details about the software offerings, just wanted to give you a little bit of the background and kind of understand how you can get HSM and where it's at and things like that. So after acquiring HSM Works back in 2012, Autodesk continued to develop HSM Works for SolidWorks. It was originally a SolidWorks program. Going forward, HSM was designed from the ground up to work inside Inventor, extending parametric design into the CAM environment for Autodesk customers. It is the most intuitive and user-friendly CAM software available. Currently, HSM requires either Inventor, okay, and it's known as Inventor HSM, or SolidWorks, and that's known as HSM Works. Inventor HSM is only available, as I said before, as part of the Product Design and Manufacturing Collection as an entitlement. So if you have been a subscriber to the Product Design and Manufacturing Collection for a period of time, this is a new entitlement. So if you're not aware of it, you can log in to your Autodesk account and you will see that entitlement there, and you'll be able to get to your downloads and be able to install this entitlement that runs directly inside of Inventor. Interestingly, the HSM Works, which is the SolidWorks portion of this program, is also available in the collection. So this really benefits those of our customers, which there are a lot of, who have Inventor but also have SolidWorks, or have team members that use SolidWorks. That's a pretty interesting thing, is that the HSM Works is available in the collection. A third product that HSM is available in is also in Fusion 360, and of course, as you know, Fusion 360 is an entitlement as part of the Product Design and Manufacturing Collection as well. So now you have it in actually, in two places inside of Autodesk products. So another utility, which we probably won't get into today at all, I think we'll plan on doing a future webinar on it, but it has ties into the HSM, and that's the nesting utility. So another entitlement that you have available to you is the nesting utility, and we'll probably do a future webinar based on that. Okay, taking a look at the features of HSM and what it does. The first thing, adaptive clearing. Adaptive clearing is a relatively new technology in the CNC world that has come about due to the advancements in the programming using Inventor. And this helps to increase your tool life and also helps to reduce your roughing time by at least a factor of 4. And one of the new updates to the adaptive clearing actually includes the addition of what we call climb cutting. It's two-way cutting. So it takes a little bit of learning to do on your machine to see what the resistance or the loads are on the tool, so that when you're going one way, what that is, and then going the reverse, what additional loads might be put on that machine. And so it takes a little bit of finagling, but that will help reduce the machine time on your parts by doing two-way cutting. So that's a new advancement in the adaptive clearing section. We also have the CAD/CAM integration. So because you're in the software interface with Inventor, you already have familiarity to the parametric workflows of Inventor, and that extends into the CAM environment, so that if you make a change to your model, your tool paths are going to update automatically. Also, the support for any CAD inside of Inventor means that your source CAD files can update automatically to reflect your tool paths, even if they are not native Inventor files. So if they're Creo or SolidWorks or CATIA or any of these other, or even neutral file formats, if that file is updated and changes are made, the next time it's loaded, those tool paths are automatically updated. So fast toolpath calculation time is another thing. Inventor HSM takes advantage of multi-processor and multi-core CPUs, which reduce toolpath calculation times, especially when you have large or complex designs. We have 2.5 axis and 3 axis milling and 3+2 positioning, so those are all included in the software. Also multi-axis operations, so simultaneous 4 and 5 axis features for machining complex models. And this includes multi-axis contouring and 3D toolpath tilting. HSM also includes turning and mill turn, so your any of your facing, grooving, and boring functions in a turning environment. Also, water jet, plasma, and laser cutting. So a 2D profile cutting path can be quickly created, which adds all contours that lie in the same plane. So this was when I was alluding a little bit earlier to the nesting utility. The nesting utility can extend into this water jet, plasma, and laser cutting environment, where you can select one contour, and all contours that lie in the same plane get automatically selected for the cutting. Probing is another thing that's been added. Probing helps you to establish your 0 point on a part, do part inspection, and probe the part model or the stock body. Tool holder avoidance is another feature of HSM. The tool holder can be included in the cutter path calculations to prevent collisions. Options include pull away, trim, detect tool length, or abort if interference occurs. And then last but not least, and this is not, by all means, not a comprehensive list. This is just top features. Engraving shapes and text. So you can carve shapes or text into parts using a chamfer tool. All right, so after that intro into the HSM tool inside of Inventor and some of its features, we'll go ahead and switch over now and go to the demo. So bear with me a minute while I share my screen. And you should be seeing my screen. And Amy, let me know if you can't see my screen.
I can see it.
Great, awesome. Okay, so what I've got here is I've got something you've probably seen from other demos of ours or across the web from Autodesk. This is a pedal box assembly from one of our demo sets of the race car model. And what I've got here is a great assembly of that pedal box, and a good candidate for an introduction to machining in the HSM environment. And so what I thought we'd look at is the pedal here for the accelerator pedal, and that's the MCH 1144. And so what we would traditionally do is open that that file, and right inside of that part environment, we can switch over to the CAM environment inside of Inventor. So we could switch right to it and then begin the process of using the tools, starting with our setup and so on, and do that part. I'm actually going to come over here to an assembly and just show you that what you can do is you can also kind of simulate what's going to be in your CNC machine. So looking here at a vise setup and our part holding vise, you can actually set this up in your environment and work from an assembly environment to do your CAM as well. So just something not only fun, but can also just help you in your CNC work of having everything positioned in as it will be in the machine. All right, so the first thing we're going to do is we're going to do the setup for this. So again, the way that you'll see HSM works is everything is very methodical, and it's similar to our FEA environment. We work from left to right and top to bottom, and so you'll kind of notice that as we go through some of the dialog boxes in the CAM browser here. So I'm going to start with the setup, and in the setup, one of the things you'll notice is we get this bounding box, which basically Inventor is assuming my stock for this. Well, this is obviously including the whole assembly, so I'll make some changes there. So one, I want to make sure I select the operation type that I'm going to do, and then for my model, the first thing I will do is I'll go ahead and actually pick the model. So here I can pick the model just inside the assembly, and it reduces it down and shows me just that bounding box of that stock that will be for that component. And then as far as an orientation for the model, I'm going to go ahead and select the Z-axis or plane and the X-axis. And so when I do that, the first thing I want to do is I'm going to zoom in a little bit here, and I'm going to select this top face of my part to be my Z-axis. And you can see that the triad rotates accordingly. So the next portion that I got to do after I select the Z-axis is then establish my X-axis. So what I can also do is I can move my stock origin point. So here I can say, well, what's my stock point going to be? And I have a drop down here, and I can click this button here and select the stock box point, and I'll come down here and pick this corner. And then now I can come up and do the X-axis, and I can just pick an axis that I know is in alignment with where I want to be. And I'm actually going to just pick this vise edge here to get my X-axis. Now you can see my triad is the X-axis is going the right way, the X is going, or the Z is going up, but I want to flip the X-axis. So right here in the dialog, I can just flip it, and so now my triad bounds, starts in the corner and bounds my my stock. So X is going to be positive to the right, Y is going to be going the lengthwise of the stock, and Z is up. So the next thing I want to do is I want to, working left to right, go over to the stock tab, and then here I can set some offsets for my stock. And so just so that this is a little more easier to see, I'm going to zoom around here, and you can see that just based on what the defaults are in here, I already have a side offset. I'm just going to go ahead and change these and get my side offsets, get my top offset, And then my bottom offset, maybe I'm just going to do something a little bit bigger, get a little stock in there to hold. And I'll go ahead and click OK. And now my setup is done. So the setup is the first thing you want to do, is make sure that that you specify your stock for your part. Now you don't have to do a probe. You can go right into generating tool paths, but I thought since it's a cool part of the program and a newer feature here, we'll start with the probe. And when I do the probe, I want to select the actual tool first. So again, I go in and I select the tool. So I'm working from the left tab. I go to select the tool, and I'm going to scroll down and look at my the tools that I have. There we go, there's probe. So I'm going to just pick a probe, and I'll just go with this 5mm. Select that. And you can see then I get my probe with my tool holder, and then what I'm going to do is select my geometry. And what do I want to select as the probe mode? I'm going to just go ahead and select the stock, and then I'm going to select the stock top surface. And I've got some options in here for probe types, and by selecting that, you can see with the XY rectangular boss, I've got different selections that I can do for probe types. So you can see the different ones that are there. I'll just go ahead and accept that, and for a tool, for a stock centering. And then a probe is something we can simulate. So when I select that probe, I can click simulate up here. And what's going to happen when I click this little play button, it's going to simulate the probe doing its operations for centering. So simulation is a method or a tool that is used to validate or verify our tool paths. So it's something that you will use often, and then once you're done with the simulated environment, we'll click close. So that simulation is done, and we come back to our part. All right, so we have our probe. It's all set up in there. All right, so the first operation that we want to do is we'll just go ahead and do a face operation. So face operation, again, allows us to pick the tool. And we're just going to go right down here and pick this 50mm diameter face tool. Now, in the Select Tool dialog box, we have the ability to create new mill tools, new mill holders, new turn tools, or create new libraries, and within those libraries have multiple tools. And then we can also make edits to the tools as we need to. So here you can see with the 50mm, I can click Edit, and it has a nice graphical representation of the actual tool. And I can go in here under my Cutter tab or any of these tabs here and make whatever adjustments I need so that this tool is properly reflected in my model environment. So I'm not going to make any changes, just wanted you to be able to see the different things you can do. You can add comments and descriptions. You can place a vendor in there, product ID, all kinds of information. Okay, so I'm just going to click OK to that 50mm face, select it, and you can see that the tool and the holder automatically show up in the environment here. So the tool is selected. So one thing with the facing operation, you don't actually have to select anything. So once you've actually selected the tool, you just click OK. And what happens is a tool path is automatically generated. You can tell by the little red arrow here, the yellow and green and blue lines, and then the green exit arrow here. So this generates the tool path. So now we want to simulate this. So one, I can select it, select simulate here, or I can right click and select simulate. And I've got an option turned on right now for stock. I can leave that off if I don't care to see it, but if I want to kind of see the whole operation, how it affects my stock or as it takes away material, I can click on that play button and let it play and simulate that facing operation. So there's some controls with the simulate for play, for fast forwarding to going to another step or going to the end, and then this little ball here that you can drag back and forth can either slow down or speed up that simulation. So you can see I can actually speed that up and make it go faster. All right, so that looks good. We like the facing operation. We'll go ahead and click close there. So now you can see in our CAM browser, we have the probe set up and we have the face set up. All right, so our next operation that we're going to do is a 2D adaptive toolpath. So when I click on that 2D adaptive toolpath, again, working left to right, the first thing I want to do is select a tool. Notice here in the top, it tells me the last tool that I selected. That's what the current tool is still selected. So I'm going to click on Tool, go down to my metric, select the 16mm flat tool. And what I'm going to do is then click on the Geometry tab, and I'm going to select that bottom edge of that feature. You can see that it's then going to calculate. It should calculate a tool path. Let's see. Let's edit that. Let's make sure we're good here. I should be getting a little arrow here. Let me zoom in and make sure we're good there. So a couple of the things you can do on the toolpath, you notice that if I select it here, I can delete that selection. I can click the checkbox. I can also use the control click to deselect that path. And I will select that. And I will click OK. And let's go ahead and do a simulate on that. I'm not seeing a toolpath for some reason. So when I go to simulate, it's not going to do anything. Tool. There it is. Okay, so now I got the proper selection. You can see the plane is selected, and I've got this arrow. This is what I was looking for in this. And now when I click OK, now it's going to generate the tool path. So there we go. So now you can see the tool path is automatically generated for me. So this is one of the beauties of this program that runs in Inventor, is that is automatic, and you can see that was very fast. So I'm going to take the right-click approach and simulate this. And with my stock option on, I can see how that tool path is going to go. Now I have full control over the speeds and the feeds and all of this, so I can go in and I can edit this tool path, the parameters of it, so that I can change anything that I want to. And you'll see that as we do some other tooling operations here. So we'll speed this up a little bit, and you can see that adaptive tool path simulates what's going to happen in the machine. All right, I like everything. So if everything meets what you intend, we'll go ahead and click close, and now we've completed that 2D adaptive operation. All right, so the next thing we'll do is do a 2D contour, and we'll just go ahead and pick a different tool. And we're going to go ahead and pick this 16 millimeter, or I'm sorry, this number 3, this 10 millimeter. And again, we're going to pick this bottom contour here, just to put a finishing contour on this. And click OK. And again, now if I want to see everything, I can select either just that one toolpath, or I can select all of them and I can simulate them all together. And then as I go, you can see the facing operation. I know that's good. I like it. I can fast forward to the next operation. So it kind of skips the facing, goes there. I like that one. And now I'll fast forward to that contour, that finishing operation on that component. So all looks good there. So we'll go ahead and click close. All right, so the next operation that we're going to do is we'll do this little inside edge here. And so again, that'll be another contour. And we're going to go ahead and when we select our material, or when we select our geometry, I'm going to select this little edge right here. Now, one of the things that you have control over here is the passes. So if I come over to the right and click on the passes, what I can do is I can select multiple finishing passes. And the reason I might do this is because if I look at this simulation, well, I'll show this to you, it's going to go ahead and simulate that path, but it's not going to clear out all the material I need because of the size of the tool that I have selected. So I can actually put in multiple finishing passes here. So I'm just going to leave that alone without it right now. Click OK, and then we'll show you that operation with all of those selected. We'll simulate, we'll play, we'll go a little faster. Go to the next one, and here we got that finishing pass, and then we'll come in here and you can see that contour that we put in. That contour follows that path, but then it leaves some material. So I have full control over that tool. So I'm going to come in here and I'm going to just select the tool, right click and edit, and I'm going to go to the passes. I'm going to say let's make some multiple passes, and we're going to try 4. I think 4 should work, but if it doesn't, we can go up from there. So we'll do that again. Simulate. And then you can see it's going to make multiple passes. So it looks like it still needs a couple more, but you can see it's taking away the materials it needs to. So I think 2 more passes is what I'll need there. So we'll close and go to passes, and we'll jump that up to 6. So you can see that you can go back and you can test. This is why simulation is important here. We want to validate what we're doing and make sure that the tool is going to work and do what it's supposed to do on our component. So get in here, and boom, there we go. Now we're getting rid of all the material. All right. So everything looks good there. All right, so the next operation that we're going to do is we're going to go ahead and take care of some drilling in these holes here. And we might start off with just kind of some spot drilling so that we can get the locations marked and not have our tool walk on us at all. So we'll just do a drilling operation. And in the drill, we'll go ahead and select the tool. We'll pick number 70, 10 millimeter, 90-degree spot drill. And then we'll come over and we'll select our geometry. And one of the things I want to do is I want to select this select same diameter. So I'm gonna click that so that all I have to do is come over here and pick one hole. And it should pick all my faces there. Let's see, let's try that again. Yeah, hole faces. Let's try this upper one here. Here we go. So you can see by selecting that that edge there, it's selecting all three that are of the same diameter to do that operation on. So the other thing I want to do is come over here to the third tab, which is heights. And in the heights tab, I want to scroll down to the bottom height. And you can see that all of these are adjustable. So feed height, top height, retract height. I'm going to go to the bottom. How far do I want to drill down? Well, I actually only want to go to the model top. So the top of the model is as far down as I want to go, but I want to select the bottom offset. So I'm going to do -0.1. So I'll select that as my model offset, and let's take a look at that and see what happens when we simulate that. So we simulate that, we click, and we get nice little drill points there. Okay. So another feature that you can use here, and you can see how easy this is. I want to basically reuse this tool, this tool path. So I want to right-click on it, and I want to create what we call a derived operation, and I'm going to drill that derived operation. So when I do that, again, even though it's derived, it kind of picks up all the same attributes as the previous tool, so I don't have to reselect anything, but I do want to change my tool. So I'll come in here and change my tool to number 30. Okay. And then I'm actually going to change this because I actually want to make sure I go to the actual hole depth here. So I'm going to Control-click that hole face, and I'm going to select that one, and you can see that the 3 holes are selected. And I do need to remember to go back, because remember this is derived, so the bottom height still has the model top selected. And I want to make sure I go to the whole bottom and take out my offset and click OK to that. So now I'll just take these two and I'll simulate those guys, and let's see what we like what they got. Switching the tool and drilling down. Excellent. So I like that. Okay, so one of the things you can do too, let me just go in here and I'm going to kind of shift select these and simulate this. We'll go fast, and we'll fast forward it here. So you can kind of see where we are in our simulation. So with the simulation, a couple things you can do is, in looking at this, is you can, showing your tool, you can uncheck that, or you can say uncheck the shaft or uncheck the holder, or show it as transparent to make the tool transparent. Your tool path can be shown differently. Your stock can also be looked at differently. So you've got a mode of standard. Colorization is by operation or by tool. But this is the neat tool that I want to show you. Show part comparison. I can actually click on that, and actually see my part in comparison to the CNC machining operations that I've done. So a nice little tool there. You can kind of see what's been done and what still remains in your operation. So kind of a little comparison tool there. Really nice. Now, one of the other things that you can do with HSM that might be a good thing, thinking about this down the road, is you might want to start your machining process before you've finished all of your machine paths, your tooling paths. So you could right-click on one or several operations, right? If we can do one or two. Let's do two. And I can right-click on those, and I can say post-process, or I can click post-process up here in the ribbon. And if I go to post-process, here in the post-process dialog box, I have the ability to select from a plethora of pre-configured or pre-listed machines, such as Siemens and Haas, Roland, Okuma. So you've got all kinds that are here. And these are all customizable, so that you can take one that exists and you can kind of make it your own for your own machine and customize it, or you can create other configs. All right, so I'm just going to go ahead and accept this one that I have selected, this Haas machine, and I'm going to click Post, and I'll go ahead and set that post out. And you can see that it takes me into this Autodesk HSM Edit. So this is a post editor, and if I wanted to do any other tweaking or edits to this, or if my machinist wants to, this is the code that's going to the machine. So this is your post process, and that can be output. And as you output that, your machine can start, and then you can come back to your part and continue your toolpath generation for the other operations that you want to do. So that's a great option, I think, to be able to do that. So you're actually got a part in the machine going while you're continuing to configure your other toolpaths. So we got time to probably show you a couple of other operations here, and so I think the next one that we would do is maybe a 2D pocket operation here, and we'll go ahead and pick a new tool. We'll pick number 5, this 4mm flat, and what we're going to do is we're going to route out these counter bores, or these pockets here. So when we select the geometry, number 4 or 5mm, make sure I got the right tool. Yeah, number 4 or 5mm. And then what I'm going to do as far as my pocket selections, I'm going to come down here and pick this bottom edge of this pocket. And I'm going to click OK. And you'll see that we get the new toolpath, and we'll take a look at that. So we'll just right-click on that, and we'll click Simulate. And let's play that and see. So you can see how that generates that pocket. Now, we're just simulating the current operation, so it looks like this material left, but remember we drilled holes before this, so those holes will actually be gone during that, before that. So you can see how we can pocket those out. And then we can kind of finish that again with another like a 2D contour, just to kind of a finishing operation there. And I'll just again select, I could have used a derived there, right? I'll just use that and click OK. And then again, we'll just simulate that. And you can see that kind of finishing operation there. So now let's go ahead and look at the whole thing. We'll go ahead and we'll simulate that. And we'll click play. We'll go fast. We got our facing operation, and then we got our 2D adaptive clearing. So one of the things that adaptive clearing allows us to do is to be aggressive with our speeds and our feeds and keep the tool at a constant pressure on our material. And we're going to, again, like I said earlier, we're going to increase the tool life, and our parts are going to come out quicker, and we're going to get some nice metal shavings off of our components. So a lot of benefits to using adaptive clearing, adaptive tooling. All right, so everything looks good there. Of course, we've got other features that we need to come back and do later on. By maybe moving this part, changing it and flipping it upside down and doing the bottom side, doing these pockets here, doing this hole here. But I think you got a good idea of how easy the HSM tools are to use in Inventor. And of course, again, if I were to go in and make some sort of edit to my model, then whatever edit I make, when I come back into the CAM environment, my tooling paths are going to automatically update. So one other thing I'll show you here is the setup sheet. I think you'll find this pretty cool. If I click on setup sheet and click OK, I'll bring this tab over to you here. What this generates is an HTML document that has the setup for this CNC. So it has everything in here as far as your WCS and all your dimensions and your stock, the total number of tools. This is going to help your machinist quickly set up the CNC machine with the number of tools and the operation order and what's going to be done. So really handy there that HTML document can be output, put it on the network and saved. Okay, so really nice feature there. And so again, one of the things we can look at is when we do the post-process, we can post-process the whole thing. So I can click on post-process, click on post, and save that post. And you can see there it is for all the machining of the entire part. And very, very fast output. So again, taking full use of multi-thread and multi-core technology for tooling and NC coding. All right. So let me end the screen share here. And so what I wanted to also put up here is some resources for you to look at. So we've got, Autodesk forums, forum for HSM, to something for you to bookmark and visit frequently for information and troubleshooting and how-tos and things like that. So the first one there is the Autodesk forums for HSM. The second one is the HSM YouTube channel for Autodesk. So if you want to go out there and look at all the YouTube videos on HSM, it's really a vibrant community, and you can learn a lot by going out there and looking at those videos. The next one is another one called the Manufacturing Lounge. Good place to go in for sources and resources and information. And then the last one is a really good website I found that you're new to CNC, would be a good place to go learn. It's called academy.titansofcnc.com. They actually have a television show. You may have seen it on your local cable channels. So that's a pretty good one too. So good resources for you to get out there and make the CNC, the machining, and the tool path generation part of your workflow as your entitlement to in product design and manufacturing collection. So I want to thank you for your time today. If you've got any questions, feel free to put them in the chat. And if you've got any questions later on, you can feel free to email me or email Amy, and we'll be sure to answer those questions. Amy?
Yeah. It looks like we had someone who jumped on late and asked, did I miss you showing anything for 2D profiling for a laser or water jet?
Yeah, no, we didn't do anything for LaserJet. Again, that's going to be something that will tie into the nesting utility. It's part of HSM, but again, I kind of figured we'd show that using the nesting utility because that's where you would probably utilize that from. So the nesting utility is another entitlement as part of the product design and manufacturing collection. And so in our next webinar, I think we'll go ahead and show the nesting utility, and then from that back into HSM using the plasma or water jet cutter to cut those profiles. So stay tuned for our next webinar.
Yeah, and you'll also receive a link to the recording of this webinar tomorrow, so you can catch up on anything you might have missed in the first portion. And I will also include those links in your PowerPoint, Dave, and the email that's going out tomorrow. So anyone who wants to check those links out, you can get those in your follow-up email tomorrow. There was another question. Had to step away earlier, so not sure if you covered this, but does this output conversational programming for Mazak CNC machines, or would it still be G code?
Okay. Let's see. Okay. Had to step away. Okay. So yeah, so the output is through the post process. I don't know if what you can do is you can actually select the machine specifically that you want, and you can edit the configuration. But this code, this post process code here, let's just send it out there. I'm not really sure. I would say it's just G code, but I'm not as familiar with the HSM editor here, and you might be able to do some stuff here where you could output it, for Mazak or something like that. But this code here was generated for the machine, a Haas machine. So if we wanted to go Mazak, there is Mazak already put in here. So again, that Autodesk has a team of for post-processing, and that's all they do is work on post-processing. So if you have something that's very specific and maybe different than maybe what's set up here as a starting point, then contact us, and we can probably get in touch with Autodesk if you need some help with modifying the configuration for that. So I guess to answer your question, it's code specifically for that machine based on the drop-down list. So that setup is done for each machine. And again, it's customizable, so you can take what's in that list and customize that to your very specific machine or setup.